So in this video lecture we will deal with the speed and velocity. So let's talk about speed. Speed is defined as rate of change of distance covered by particle. So you can say that speed can be defined as the distance covered divided by the time taken by the particle. Speed is a scalar quantity. Speed cannot be negative. It cannot be negative. SI unit for speed is meter per second, as you all might be knowing. Next to it, speed can be categorized in two ways. First is average speed. Average speed. Average speed is simply, I can represent it in this manner, average speed. Average speed is simply total distance covered by total time taken by the particle. Second one is instantaneous speed. Instantaneous speed. It's defined as, you can see that all the instantaneous rate of changes can be defined with the help of differentiation, which we have already gone through. So if I want to talk about instantaneous speed, then I can say that instantaneous speed is simply dx by dt, where dx is the distance covered in a very small time interval dt. So that way, with the help of differentiation, we can define instantaneous speed of a particle. Let's take an example for calculation of average speed and instantaneous speed. For example, there is a person standing at this point, let's say A. This person moves from point A to his school, that is B. While moving in forward direction, he moves with speed v1, and while coming back, he moves with speed, let's say v2. So what we are required to do is we have to calculate his average speed. We have to calculate the average speed of the person. So in order to calculate average speed of the person, we have to suppose that the distance between this point and this point B, this point A and this point B is, let's say, D. Then the total distance covered by the person in the forward direction is D, and the distance covered by the person in the backward direction is again D. So the total distance, we know that average speed is simply total distance covered by total time. So total distance is 2d, d going in forward direction and d next d is in coming back to the point A. And total time is combination of two times, time of upward journey and time of downward journey. So time taken in the upward journey to cover this distance d with speed v1 is distance upon speed. This is time of upward journey, and again this downward journey time will be d by v2. So d and d will get cancelled, and what we'll get is the average speed of the person while moving from point A to point B and then coming back is simply 2v1 v2 upon v1 plus v2, this way. So this was the average speed of the person while moving from point A to point B. Now let's take one more example. For example, let's say there is an insect at this point A, and this insect start moving in forward direction along this circle, and let's say this angle covered by the insect is, this point is, let's say B, this point is B, and after crossing this point B, the insect moves to point C. This angle is, let's say, 30°. The next angle is somewhat 60°. The radius of the circle we are taking to be r. Then in this journey from A to B, the speed of insect is v. In this journey from B to C, the speed of insect is 2v, and in the remaining journey the speed of the insect is 3v. What we have to do is, we have to calculate the average speed of the insect during the whole journey. This is the question. Average speed of insect during the whole journey. This is what we have to calculate. So to calculate the average speed of the insect during the whole journey, what we are required to do is, we have to calculate the total distance, which will be simply 2 pi r, because the circumference of the circle is 2 pi r, and time will get divided in 3 parts: time of journey AB, time of journey BC, and time of journey CA. Here I can see that the total distance in 360° angle is 2 pi r. If I divide it by 12, I'll get 30°, and here I'll get pi r by 6. So in 30°, the length of the arc will be pi r by 6. So to calculate this time, I have to use this distance. The distance is pi r by 6, and it is covered with speed v. So this is time between point A to point B. Similarly, for journey from B to C, the distance will be simply pi r by 3, that is double of pi r by 6, because the angle is also double, and speed 2v. And the last phase, the distance I have to calculate. This angle is 270°. This is 270° angle. So if I multiply it with 9, I'll get 270° angle, and here I will get, if I multiply it with 9, 3 pi r by 2. So this is 3 pi r by 2 covered with speed 3v. So 3 gets cancelled with this 3, pi r, with this pi r. What I'll get is 2 by 1 by 6v plus 1 by 6v plus 1 by 2v. And if I take LCM, what I'll get is 6v here, and 1 plus 1 plus 3. So overall I'll be getting average speed of the journey to be 12v by 5. This is the average speed of the insect for the whole journey from point A to back to the point A again. Let's take one more interesting example, including speed, in fact average speed. This is a very famous and a common example that I am taking here. Let's say there is a train coming towards this signal. This is a signal light. There are 3 colors in a signal light: black, let's say black, green, and red. Okay, so this is a red light signal for a train. Maybe there is a bird sitting here on the signal. As soon as the train crosses this pole, which is at a distance of around, let's say, 240 kilometers. This is a sort of a hypothetical question. The motion of train is with speed 30 km per hour. and the speed of bird is, let's say, around 50 kilometer per hour. Now the question is this: the bird start moving from pole as soon as it sees the train crossing the pole AB. As soon as bird sees that the train is crossing this pole, the bird start moving from the pole with a fixed speed of 50. The speed of bird is fixed. It do not change. It can change its direction, but the speed of the bird is fixed. That is 50 km per hour. So as soon as this bird observes that train has crossed pole AB, the bird starts moving. Bird. And what will happen now is bird just touches the train and bird moves back to its original position. Then again bird comes back to the train with same speed and returns back. The process keeps going on until train reaches this signal. So at the last, what we observe is this bird keeps on touching this train very fastly, like this. So bird touches the train and moves back. This process is continued till bird reaches the signal. So what we have to find is find total distance covered by bird during its whole journey. We have to calculate the total distance covered by the bird. This total distance, the length of this total path, this is what we have to calculate. This total path we have to calculate. So some of the students might be thinking of creating some kind of series or some kind of pattern to observe so that they can calculate the distance, but there is no need for doing all that. What we have to analyze is that the speed of the bird is fixed, that is 50, and if bird moves for, let's say, 2 hours, whatever be the direction of the motion of bird, we have to calculate distance, not the displacement. That is why, if, let's say, if bird continues to move for 2 hours, then the total distance covered by the bird will be 50 km per hour into 2 hours, that is 100 kilometers. So this train will take around 8 hours to move to the signal. Time taken by the train to move to station is distance upon speed, that is 8 hours. So the train will take 8 hours to move from this pole AB to this signal, and during these 8 hours bird is continuously moving with speed of 50 km per second, and it has never stopped. So in those 8 hours, distance covered by bird will be simply 8 hours is the time duration and 50 is the speed. So the total distance covered by the bird is 400 kilometers. So that way we can simply solve the question. Now let's talk about velocity. Let's talk about velocity. Velocity is simply defined as rate of change of displacement. Rate of change of displacement. Again, some of the properties of velocity are like it's a vector quantity, its SI unit is same as that of speed, that is meter per second. It's represented in this manner, v vector. It's also of two types: average velocity. Average velocity is simply total displacement covered by total time taken. Next is instantaneous velocity, which is dx vector by dt. So this is instantaneous velocity and this is the average velocity. So let's take a simple example of velocity. A particle moves from this point A to this point B. The radius of the circle is 1 meter. The particle keeps on moving with a fixed speed of 2 meter per second. The speed of the particle was fixed during its journey from A to B. Okay, this speed was fixed, constant speed. So what we are supposed to do is we have to calculate average velocity of particle from A to B. So to calculate average velocity, let's see the solution. To calculate average velocity, what we have to do is we have to track what is the displacement and what is the time taken by the particle in moving from point A to point B. So the displacement of the particle is this, I think 2r, isn't it? This is the displacement of the particle, the line joining the straight line, shortest straight line joining point A to point B. So the displacement is simply 2r, and the time taken by the particle to reach from point A to point B will be given by distance. This distance of semicircular track, which is pi r, and this pi r distance is covered with speed of 2 meter per second. So pi into 1 by 2, this is the time. So overall we can calculate the average velocity to be 2 into 1 by pi into 1 by 2, that is 4 upon pi meter per second. So this is the average velocity of the particle from point A to point B.